a stone is catapulted at t is equal to 0 with an initial velocity of 20 meters per second at an angle of 32 degrees above the horizontal. What is A, the magnitude of velocity after 1.8 seconds and the displacement on x and y axis? B, the maximum height reached by the stone. C, the total time in air. And D, the maximum range. So we draw the trajectory of the stone and try to use SOHCAHTOA to obtain the components of velocity, initial velocity. So for here it will be v naught sine theta, theta naught. Let's say the 32 degrees is theta naught, while on the x-axis it will be cos. It is v naught cos theta naught. So let us now solve the first one, which is the magnitude of velocity after 1.8 seconds. So what we are going to do is to use this formula. V is equal to v naught plus at. And first of all, you should know that acceleration due to gravity acts downwards. So our ay, because it's along the y-axis, is equal to minus g. So for the white component, we get vy is equal to v naught y is equal to v naught sine theta naught minus gt. So that we will now have it to be, let me put it here, 20 sine 32 degrees minus 9.8 times 1.8, and that will give us minus 7.0416 meters per second, minus, because it's now coming down. I think it should be somewhere here. It's now coming down, vy at that time. The horizontal component will be vx is equal to v naught x minus, if you like, axt, but there is no horizontal component of acceleration, so it's equal to 0, and we have gotten it to be v naught cos theta naught, which is equal to 20 cos 32 degrees, and it is equal to 16.9610. We will now get the magnitude. So we say it's equal to vx squared plus vy squared, which is equal to square root of 16.9610 squared plus minus 7.0416 squared, if you like. So if you do it, you will get the answer to be 18.37 meters per second. So that's A. For the AII part, we are going to get the various displacement along the x and y axis. So the first one we will use from s equal to v naught t plus half a t squared. So to get the first one, which is the x component, we have told you that there is no horizontal component of acceleration, so this guy is 0. So we have that x is equal to 20 cos 30 is 16.9610 times t, this t 1.8, and we'll get it to be 30.53 meters. So along the y-axis we use the same formula, but in the white component, so it will be y is equal to v naught sine theta naught t minus half gt squared. So if we plug in the values, 20 sine 32 times the time, 1.8 minus 9.8 over 2 times 1.8 squared, 3.2 meters. The B part says what is the maximum height reached by the stone. So the maximum height reached by the stone, we can find it by using this formula. B, we can find it by using this formula. V y max, if you like, squared is equal to V naught y squared minus 2g y max. And of course, you know that we got it from V squared is equal to V naught squared plus 2as, where our s is displacement. So at maximum height, this guy is zero at maximum height. So we put 0 is equal to, this is from what we did last time, decoupling the vector triangle, the triangle. We find out that here is V sine theta naught. So V naught y is V naught sine theta naught all squared minus 2g y max. So our y max now becomes V naught. Okay, let's plug it. 20 sine 32 squared all over 2g, that's 2 times 9.8, and if we do it, you will get 5.73 meters. That's the maximum height. Quickly, let us go to the C part of the problem, the total time in the air. So the total time in the air, you know that the total time in the air will happen when the vertical component of displacement is 0. So y will be 0, minimum if you like, is equal to V naught yt minus half gtf squared. Our t now becomes the time of flight because y is 0, and we got this equation from, of course, we know s is equal to, if you like, V naught t plus half at squared. That's where we got the equation from. So we say 0 at the floor, at the ground where it took off, is equal to V naught sine theta naught minus half gtf. Then we put time of flight here, so that the equation still holds. This equation still holds. So that you know, this is a quadratic equation. So that either tf is equal to 0, or this whole thing in the square bracket is equal to 0, or V naught sine theta naught minus half gtf is equal to 0. So that if we make subject formula for tf, we have it that this will be V naught sine theta naught over 2g, like that. So if we plug the values, it will be 2 into 20 sine 32 degrees all over 9.8. So the answer from here is 2.16 seconds time of flight. That means that the time to reach the maximum height will be half this, which is 1.08. So let us quickly round this stuff up by doing the last one, the D part of the problem. The range has the maximum horizontal distance. So the maximum horizontal distance, we have seen that in projectile the horizontal component of velocity is constant. So the range, or the maximum horizontal distance, is equal to V naught x tf, because by the time it will land on the ground, the maximum rate it has flown and come to the elevation where it took off. So it's equal to V naught cos theta naught times tf. So if we now plug the equations, the values, we have to equals theta 32 times TF now is 2.16 seconds, and if we do it, we will obtain an answer of 36.64 meters. So ladies and gentlemen, this is how to do this in a nutshell. Thanks, and please subscribe.